Good mythical morning.
Hello.
Yeah, morning. All right. How you guys?
Mythical or mythical?
No, you
Duh.
messed up for sure.
I know, right? See, yes, I did say mythical morning. Okay. So, anyway, okay, so definite integral. So this notes is super different than what's in the book. So I pick and choose the examples I'm using, right, Pitar? So if you're trying to follow from the book actually goes into great detail about this. Great detail. But I'm only hitting the parts that you really need to know. Okay? So there's certain things and I'm going straight to the ones that we need. Yes.
I have all of them but 5.2.
That was that single page. It's right over there. Yeah, everyone had that problem when we were passing these out. Whoever was assigned to pass out 5.2, really struggled with that. It's in the file thing right there. Nope. That one. Yes. That's all the calculus stuff. So somewhere in there is 5.2. Okay, so now I really want to point this out. Make sure that you guys are paying attention, not doing your homework that should have been done. We are going over this and following along and all that good stuff. Now, this, we are going to make a formula out of this. And I'm going to show you because I hate giving formulas. I really do. I think formulas are something that are very tedious. If you understand how to make your own formula, then it makes math a lot easier. Because if you understand where the formula or how you get the formula, everything, it's like, like you hear like little angels, singing and stuff. So anyway, all right, so I'm going right here. Okay, forming Riemann sums. So it says for the function, blah, from 0 to 6, that means my interval is from 0 to 6, and I'm including both 0 and 6. Partition the interval into 4 subintervals, so that means my n is equal to 4. For the Riemann sum, for which left endpoint, each subinterval, and then midpoint of each subinterval. Now, Riemann sum is either left-hand alignment, right-hand alignment, or midpoint. Okay, so I will talk about each one in detail. So we could do left, right, or midpoint. There's actually a Simpson one to go along with that, but I ain't doing that. So let's first take a look at what we got here. So for my function, I have this function right here, right? Say yes. Okay, good. So I'm going to start off by, I'm going to the next page to do it. Oh, no, wait, not next page. Insert page after current. So it was an x squared minus 3, right?
Yes.
Yes, so x squared minus 3. Okay, so x squared minus 3, and it is the interval from where to where?
0 to 6.
0 to 6, right? So this one's going to be pretty big. Okay, so let's see, that's 6 there. That makes that 3, and that makes this 1 and 2 and 4 and 5. Yeah, go ahead. All right. So I'm just trying to sketch a graph so I could actually have something to work with here. Now, let's go back to my function, which we said was f of x equals x squared minus 3, and my interval is from 0 to 6. Oh, wow, that is a 6. And n equals 4. So, I'm drawing this out to try and help myself later on. So first thing I'm going to do is actually figure out my delta x. My delta x, the thickness of this, so it would be 6 minus 0 over 4, which is going to give me 6 over 4, which reduces to 3 over 2. Okay, so leave it as an improper fraction. I had someone try to do a mixed number, and mixed numbers don't multiply very good. So you got to turn it to mixed number, improper fraction anyway. Okay, so that's a start. So now we're going to do a left hand. So left hand means that when I draw a rectangle, I'm going to have everything is going to be on the left side. Every alignment is going to be from the left side. So I'm going to go with blue here. So let's see. If I start at 0, then my first interval is going to go from 0 to 3/2, which is going to be right here. And there's 3/2, right? So I'm going to draw my first rectangle like this. Watcher, you okay?
Yes.
You're zoning out there.
No.
You good?
Yeah, I hope.
Okay. All right, next one. So my next interval, I'm going to add how much? 3/2. So I'm adding 3/2 to my previous one. So 3/2 plus 3/2 is 6/2, which is 3. Okay, so that's my next one right here. So I'm going to line it up right here. Boop. And just so you know, for those people in YouTube land, this is not drawn to scale. Yeah, because I think my next one's going to screw it up. Anyway, all right, so for my next interval, it's going to be another 3/2. So if you notice, I was counting by 3/2. So it's hopefully going to help you. So this was 6/2. And add another 3/2 is 9/2, which is going to put me at about 4.5, right? So 3, 4, right? About here. Yes? Okay, good. So it puts me right there. And so that was 9/2, and then my last interval should put me at 12/2, which is 6, right? So something like that. All right, again, the not to scale thing. Is everything okay? Okay, again, not to scale. So we're lining up to the left side. So that means that every one of my intervals is always going to be on the left side. So let's start out first. So left means that my rectangle goes this way. All right. And now area under the curve. This is something super important that's kind of complex to understand. No, it's not. So that means that this area for the first rectangle is negative. I get a negative area for the first one because it is below the line. Down here, what's your height? Your height's -3, isn't it? So your width times your height is -3. Because area under the curve always stops right up here at the x-axis. That's the reason why we always are stating that it's bounded by the x-axis. So it's going to be above the line. But anything that is below the line is a negative value. And it is a negative value. Okay? Yes, no, maybe? You guys don't believe me? No? All right. Okay. Be skeptical. Take out your calculator.
So it's the same thing as 5.1, but it's just flipped. Now we find an area on the rectangle.
No. Nope.
It does make sense though. It does make sense, 'cause like, remember last year, guys? The example he used to find this, is like, you know where it's like, I need to buy grass or something, right? So like, if you find the thing, like, what do you call it? Paper stuff, as like your yard, right? board starts at, like your board starts at the X? What? I was wondering. No, that was pre-cal. Anyway.
He was here first semester, not second.
Yeah, but that was 3/4, because I remember he came into the class. Yes, for my class. So like, isn't this right?
I would not say close. That's the one time.
All right. So I'm pulling up mine, especially for those people out in YouTube land. Okay, let's go to my graph. So I'm going to have you guys do something here so we know, so you can understand. So let's just start off with a trig function that we know that a trig function, sine and cosine, is a wave, right? Okay, good. So I'm going to go trig, and I want to go with the sine of x. There we go. And menu, I'm gonna change my window to be a trig window. So I have it from 0 to 2 pi. Yeah, window.
Windows settings,
Yeah.
0, X max is 2.
Oh no, you don't have to do that. Look, just go menu, window. There's already a trig setting.
Oh,
I'm sorry, did I do that? I might have actually just did that too fast for you guys. Okay, so yeah, just trig. Just change it to trig. And it automatically goes from 0 to 2 pi. Now, again, these calculators are super smart. So watch this. Menu. I'm going to analyze the graph. And we're doing an integral now. Right? Antiderivative is the integral. Lower bound. Okay, so yes, it gives you like a little dotted line to actually move, but we actually have real values. So let's go ahead and just start with, just plug in the number. So I want from 0, so enter 0. Just hit the number 0 and hit enter. And upper bound would be 2 pi, right? So upper bound, I'm just going to go 2 pi, hit enter. So if you notice, I have area above the curve and I have area below the curve, don't I? Yes? Okay, so this calculator estimates, and it is super, like, yeah, close to an answer. But if I have 3.6 and e to the negative 15, that's a scientific notation. If you think about it, that's times 10 to the negative 15. That means that there is 14 zeros in front of this 3. So I could assume that this number right here is 0. Your calculator, you know, because it does estimates all the time, and pi is one of those irrational numbers that you can't really, you know, just have, you know, it doesn't say in that this is 2 pi. You just need to know that 6.28 is 2 times pi. Right? Yes? Okay, good. So this is going to be 0. So it says that my area is 0. That's pretty interesting. I have area here, don't I? I have shaded up here, and I have shaded down here. So I have shaded, all this shaded, but somehow my area is 0. So now I'm going to do it again, but I'm going to change my bounds. Menu, analyze graph, integral again, and we're starting at 0, And I'm just going to go to just pi this time. Instead of 2 pi, just pi. Hit enter. So my area now is just 2. So the area for that piece right there is positive 2. So if I know that the total area from 0 to 2 pi for this wave is supposed to be 0, what does that leave me to infer from pi to 2 pi my area has to be? Has to be negative 2, doesn't it? So let's check that. Do it again. And starting at pi. And going to 2
Yes.
pi. Look, my area is negative 2. So anything below the x-axis is a negative area. Anything below the x-axis is a negative area. So that's how we're able to actually do some of these. So the total together is going to be 0. Does that make sense now? You guys believe me a little bit better?
Yes.
Okay. So all right, so here we go back to this again. So a left-hand alignment means that my area of my first one right here is going to be 3/2 times negative 3. Plus the next area. Okay, so now if it has to be a left-hand alignment, let's figure out what the point is going to be. So at 3/2, what's my function supposed to be? F of 3/2. So if I go through and do this, let's see. Let's see. Do you know what? I'm just going to do this right here. 0 to 3 over 2. And my next interval is going to be from 3 over 2 to 3. Next interval is going to be, what do we say, 9 over 2? And to, no, 3 to 9 over 2. And my last one is going to be 9 over 2 to 6. Okay? So I'm just listing out the intervals because I know I'm going to have a left-hand alignment every time, right? So in my left-hand alignment, my first one had to be at 0. My second one has to be at 3/2, right? So I need to know what f of 3/2 is. That's going to be 9 over 4 minus 12 over 4, which is negative 3 over 4?
Yes.
Yeah, negative 3 over 4. Yes? Okay, so I'm going to have 3/2 times negative 3 over 4. Plus. Now, the next one has to be f of, come on, people now.
33.
There we go. All right, f of 3. So let's check that out. F of 3. So f of 3. So we need to plug that in. So it's going to be 3 squared, which is 9, minus 3 is 6. And next one. Left alignment, it's going to be 9/2, right? So f of 9 over 2. 9 over 2, so that's 81 over 4. 81 over 4 minus 12 over 4 is 69 over 4? What? Yeah, 69 over 4, right? Just making sure. Yes? Yeah, okay, good. All right, so 69 over 4. Now, I wrote it like this for a reason. Okay, a very, very good reason. Okay, this is the point of the class where we actually make a formula out of this. We're making a formula out of this. Is there a common factor, a common multiple in each one of those? 3 over 2. Where did we get the 3 over 2 from? The interval, which was my delta x, right? So it's basically going to be, if I was to try and do this again, would I have to go through and do all that together? Okay, I know that there's going to be a common factor of my delta x, because every time I'm doing one of those intervals, I'm multiplying by the thickness, which is my delta x. So I could basically say I have, look, I'll even change the color on this one because that's how important this one is. Delta x, right? My thickness times, because I'm going to take this common factor out. Ooh, oh, sorry. I'm going to take the common factor out. So what's going to be left after I take out that common factor? Yeah, the y values, right? So that's going to be basically f of x from the first one plus f of x from the second one plus f of x from the third one. Come on now. Now, if I had more intervals, if it said n equals 10, I would actually just have to have 10 of these, right? So it would actually have to go from my 10th, or all the way out to my 10th interval. Right, Pitar? Okay. So, mathematically, I could just pull out that 3/2 now, can I? So I'm trying to slow roll this into getting to our formula for this. So we can do this individually, but then it's a little bit easier to just say this, right? My 3/2 times my end result. So add together all my y values or my f of whatever, okay? And then multiply by 3/2 at the end. Was it -3 plus negative, what was it, something over 4? 3 over 4 plus 6 plus 69 over 4. Okay, we could add those together. I'd make it a whole lot easier, right? What do you get, 39 over 2? Okay, he's got 39 over 2. So it's 3 over 2 times 39 over 2, which is going to give me, let me see, I don't know.
57.
What is it? No, because it's 9...
117.
117? So 117 over 4. And this is area, right? So it is my units squared. Now it's a good good habit to get into, to always put the unit squared in there. Understanding that there's area, because when we get into the AP style questions again, this is just introductory to part of that. And so everything's going to have units anyway. So let's get in the habit. So when you're finding the area of something, it's going to be a unit square. What's up? No. Because it's 27 plus 90. Yeah, 27 plus 90. Yeah, there we go. So that's not too bad, is it? Okay, so now this is the left-hand interval. We did this one right here. Left-hand endpoint. So Riemann sum for the left hand. Now we're going to do midpoint. So midpoint now is going to be same delta x though. Same delta x. So now I'm going to go to my new page, which is going to be right here. Tools, insert, page, after. So we're going to have my intervals. So I'm going to rewrite that again. What was it? 0 and 3 over 2 and 3 over 2, comma 3 and 3, comma 9 over 2, 9 over 2, and 6. There you go. By the name of midpoint, what do you think we're going to be using? Okay, midpoint formula. Okay, so if the left Riemann sum means in each interval use the left number. If a right Riemann sum means in each interval use the right number. The midpoint formula, find the middle in between, right? Okay, that's what we're doing. So a lot of the same stuff. It's just I'm doing a different style here. So for each midpoint, it's going to be f of the middle. And if you guys remember, it would be b minus a over 2 for each one. For each interval, it's b minus a over 2. So that's finding the average in between these two values. So in this case, it's going to be 3 over 2 divided by 2, which is 3 over 4, right? So my first one here is going to be f of 3 over 4. What, true? You agree?
Yeah.
Okay. So you have that look like I made a mistake. Okay, all right. Next one. Next one right here. So now, let's see, this is going to be, what's that going to be? 6 over 2 minus 3 over 2, which is 3 over 2. It can't be 3 over 4. How do I find the midpoint between those two numbers? You add them. Seeing if anyone's awake here. So my first interval is right. That's what I was hoping someone would point that out. So it should be b plus a over 2. It worked for my first one because it was a 0. Pacho's petting zoo. Okay. The teacher's gone, so they came to me as backup because I'm the only one that they can count on. All right, so the next one. Why, true? I was hoping you would call me out on that one. Like everyone just staring at me awkwardly. So it should be b plus a divided by 2. To find the average, right? So this is going to be 6 over 2 So that's 9, right? So it's going to be 9 over 2, and it's 9 over 4 as the midpoint, right? Next one. F of 15 over 4. And my last one. What is it? 21 over 4.
I'm gonna go to the restroom first, and then I'll make a call.
Okay. All right, so we have our values now. So now for my intervals, I know I'm going to have a delta x here, right? And my delta x, is my delta x still the same? Yes.
Yes.
Delta x is the same because that's my interval length, right?
Yeah.
That's the width of every interval. So my formula is going to look like this. It's going to be delta x is 3 over 2 times the quantity of f of 3 over 4 plus f of 9 over 4 plus f of 15 over 4 plus f of 21 over 4. Okay. Let's go back to that handy dandy calculator. And you will be happy about this trick as long as you're not asleep. So I'm going to go Doc B. I'm going to clear my calculator first. And here's my graph. So now, given my graph, what was the function? What was my original function? X squared minus 3, right? Okay, so let's take a look. Let's plug it in. X squared minus 3, hit enter. Yes? Okay, good. So I could find the area by doing the math part. Or just doing, find the integral from here to here. But this is a specific problem that you need a specific answer. So I'm going to go out of there. Now, I'm on my scratch pad. But, okay, all I did just put in the graph. That's it, right? So watch this. So my delta x is 3 over 2. Okay, open parentheses. Now, I already have everything, like my function, already in the first thing, right? So hit this button right here. This is vars. Vars right here. It's above the 9. And it gives you option to select a function. And that is my first function. And what was my first number I'm finding? 3 over 4, right? So 3 over 4, close, plus my next function. So it's again vars, and I want 9 over 4, close, plus. This is one of those things that the calculator helps you. It was at 15 over 4?
Yeah.
So if you know how to do this and you don't sleep through this lesson, then you are going to be that much better. And 21 over 4? Right, there's all my stuff right there. And the settings on your calculators right now are automatically set for fraction anyway. So fractions are your friends, not food. There we go.
Well, it's just 1/8 off the 53.
It's what?
1/8 off of the 53.
Of 53? Yeah.
So it's like 52.725.
Okay. 52 point what?
I'm guessing.
Okay, so what was the other one we just did? What was the other answer we got for the left?
117 over 4.
Okay, so 117 over 4. Now, to not get a fraction, to get a decimal, you just go Control Enter. This is 29.
It's 52.
Okay, so we go Control, right? Dang, is that a big difference there? Now, could I have done this the first time from my first function? Yeah. So, let's see. 0. What was my next interval? 3 over 2?
No, it was,
Oh, for the left hand.
oh,
For the left hand was 3 over 2, right?
no, 3 over 2 is, no, it wasn't it, -3, -3 over 4?
No, 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 no. No, those are the actual values.
Oh,
I'm just doing the functions of it.
okay.
So it was the left, which is 0. Then it was 3 over 2. Then it was 3, right?
9 over 2.
And 9 over 2 was my last one. Yes, Q? Go ahead.
Are we gonna need calculators for our homework?
Huh?
Are we gonna need calculators for our homework?
Probably. It makes it easier. So I'm trying to help you with this. And like I said, the school hasn't ordered the ones that I got the check for yet. So I'm hoping we could get those here soon.
Yeah, that'd be very.
I'm trying. Okay. Okay. I'm gonna leave off with that. Okay. You guys have more than enough to be able to do.